How would you feel if one of those news stories was about a member of your family or a friend? Could you accept that a crucial medical device just didn't work properly, that wrongly labelled anaesthetics were used, that a vital medication was delivered out of date, that a vital gas was contaminated? Ask yourself, would I work for any company that knowingly set out to produce any substandard healthcare products like those? No. Of course not. No one in their right mind would. And all of us as consumers, especially when we're sick consumers, have every right to expect that such items should be completely and utterly suitable for their job. In reality, and quite rightly, we'd be very upset if they were even accidentally damaged or contaminated during manufacture. These are products that have to be taken almost entirely on trust because, generally, their quality can't be judged before use. There's just no room for chance in the sustained effort to achieve that level of confidence in the quality of every single item, week after week, month after month, year in, year out. What are we actually talking about? Well, virtually any product that is designed to cure or modify our health that we apply, take orally or inject, not forgetting the syringe itself. The list is very long and extends from eye drops and contact lens solutions, and the lenses, of course, inhalers and their contents, cough medicines and powders, skin treatments, orthopedic implants, anesthetics, medical gases, sterile infusions, vaccines, cough drops, and increasingly cosmetics. Yes, even cosmetics. Sadly, a handful of products do reach the market in unsatisfactory condition. And during this program, you'll learn how to achieve the right quality and your responsibilities and personal contribution to that quality. Only a very few generations ago, possibly not long before your grandparents were born, someone who was injured in an accident, had an operation, or had been wounded in battle was as likely to die from infection as from the trauma of the wound itself. Even recently, life-saving healthcare products were often made incorrectly or contaminated, causing fever and the deterioration of the patient's condition, and could lead subsequently to death. One of the culprits was the manufacturing process. But why? To control the quality of healthcare products, governments created regulatory authorities such as the FDA, the United States Food and Drug Administration. In the United Kingdom, there's the MHRA, Medicines and Healthcare Products Regulatory Agency, and similar bodies in countries where healthcare products are manufactured. Universally, this is achieved by the application of a quality system setting out the principles or rules for good manufacturing practice, or GMP, sometimes called Current Good Manufacturing Practice, or CGMP, all backed by the force of law. GMP applies to the entire manufacturing process and starts with incoming raw materials and components, their warehousing and handling, the physical production of the product, packaging and distribution. Laboratories are also subject to the disciplines of GMP. Most important, and at the heart of GMP, is quality management and systems, whether for medicines or medical devices. The global GMP definition of product quality is that it must reach the customer, that is, the patient, in a state fit for its intended purpose. Fitness for purpose means being the right product, of the right strength, properly made, sealed in the right container, properly labelled, uncontaminated, and in its anticipated effective lifetime. In fact, a product precisely to specification. This isn't a target, but applies to each pack, to each tablet, capsule, component, each gas cylinder, each tube, each dressing, syringe, each ampule, and each whatever the final form. The virtual universal availability of effective and safe healthcare products can be achieved by amazingly few but comprehensive core GMP principles. Let's review them now, starting with the rule that every action will be undertaken only by following written instructions, that quality must be proven or validated and controlled at every stage of the storage, handling, manufacturing and packaging cycle, that raw materials and components must be stored and handled correctly, and that exactly the right materials must be used at all times, that equipment and the environment in which it's installed are appropriate for the purpose and always properly cleaned and treated, that products will only contain ingredients and be produced as specified, that everything is correctly identified and labelled at every stage of production and distribution, that everyone, production and support staff, must dress and behave as required, be properly supervised, and above all, be trained correctly. That all work must be undertaken precisely and accurately. That contamination of materials must be prevented at all times. And that accurate records are kept at every stage. Make no mistake, the consequence of products hazardous to patients' health is awful, and regulatory agencies are tasked to prevent that from happening, if necessary, by levying very substantial fines or by stopping your production. Not that long ago, when your grandparents were still young, quality was assessed and controlled by end product testing. It was assumed that by taking samples from a batch of finished products and then testing them, it would be possible to guarantee the quality of the whole batch. But think about it. In fact, it guarantees only the quality of each sample, and that never gets to the patient. Virtually every domestic or industrial product we buy can be examined and rejected or replaced if found to be faulty or damaged. But to test most of the items we're concerned with, you must destroy them. Over the years, it became apparent that the better way to ensure continuing quality standards is to make certain that mistakes don't happen. To achieve that, it was recognized that the control of quality requires two separate but interrelated functions, called quality assurance and quality control. Quality assurance is proactive and entails the systematic analysis of each process in order to pre-plan and then document how every activity will be undertaken, so assuring that, when carried out precisely, the outcome will be as expected. This concept, that quality must be built into the product from the beginning, demands that everyone and everything that may have even the slightest influence on the product will be pre-examined and predetermined. Consider the implications of those two words, everything and everyone, because they demonstrate the formidable challenge represented by assuring quality. In addition, there's the people side, where personal hygiene, gowning considerations and training needs have to be planned. And of course, the documented methods for handling corrective actions as they arise at every stage of the process, including product recalls and products returned by customers. So, quality assurance creates and documents the instructions for what will be done. Quality control provides the physical verification that it has been or is being done. This includes the actual sampling of incoming raw materials and components, as well as during manufacture. Quality control samples water quality, that the environment is as specified, and whether environmental and process equipment cleaning has been done correctly. Dependent on the products being manufactured, quality control involves chemistry, biology, and microbiological laboratories. To summarize, the quality department must ensure that the finished product is fit for its purpose, and that each individual dose or component is made to the correct formulation and is free from contamination, that it will reach the patient in the correct container and packaged to prevent damage or contamination, and will not have deteriorated during distribution. Remember, before use, it's virtually impossible to detect whether a medicine has been made correctly, so we must be confident, absolutely assured, that the product has been made as specified. Validation is a word that's bandied about a lot, often not very fondly. But it's a fundamental aspect of regulatory compliance. And to understand GMP, you must know what it is and its implications. In a nutshell, to validate something asks simply that we prove and document that it works consistently as specified. Validation is another of those simple ideas that can become horribly complicated when actually put into practice. It's a natural extension of the principles of quality assurance, but validation asks that, in addition to pre-planning, we actually prove and document that it will work, as near as humanly possible, 100% effectively, 100% of the time. A validated project makes good sense because reliable and repeatable production, the outcome of good validation, is cost-effective through the reduction of equipment design failures, production faults, rejects and reworking, while achieving its goal to enhance quality standards. Crucial principle of GMP, that nothing may be left to chance, is covered by the fundamental rule that everything will be completely documented. When 100% accuracy and consistency are the only acceptable result, it's just not realistic to rely on memorized or word-of-mouth instructions. It's a fact of life that, regardless of our individual qualifications and good intentions, the only guarantee that we'll work to this level of consistency is always to follow detailed, clear, and written instructions. Documentation plays a crucial role with its twin functions to provide both instructions of what must happen and subsequently records of what did happen. Instruction documents are subdivided into 3 categories, starting with specifications that specify the standards or measurable performance of materials to be used. For example, there are specifications for incoming raw or primary materials, and for packaging materials such as containers, labels, and product information leaflets. Second group of instruction documents is manufacturing and packaging instructions, and here the documents are specific to the particular product to be made and will detail which materials are to be used, the quantities of materials needed, which items of machinery or equipment will be required, and the procedures and quality checks to be followed, either to manufacture or to package the product. A batch manufacturing and a batch packaging instruction is issued for every batch being made. No matter how many times this has been done before, it's essential that the new documents be referred to each time. In fact, to ensure that this is done, each document has to be signed in the appropriate place by each person involved. Documents in the third group are often described as standard operating procedures, usually shortened to SOPs, that detail activities that are not specific to any one product. They range from the methods used in warehouse operations for the receipt and handling of raw materials, packaging items and products, the procedures to be followed when dispensing materials, how to clean manufacturing or packaging areas and equipment, what sort of clothing and other items such as eye protection and gloves are needed and how to use them, how to operate the water system, how to clean, set up and operate each machine, even how to move materials from one place to another, and environmental testing. Again, note that laboratories are included so that all procedures are undertaken consistently, as are how to handle the problems arising from mistakes which have been made either immediately or when complaints have been received. There should be a standard operating procedure for every eventuality. The final group of documents is records. These obviously record what's been done. The important thing about these documents is that they must record clearly and precisely, complete with the time and date when it was done, at the time it was done, not later in the day or tomorrow, that every instruction was carried out. Incorrect entries must be shown as such. We all make mistakes, but there should be no attempt to obliterate it. Wrong entries must be corrected, dated and signed. Entries should be countersigned by the supervisor or an appropriate colleague to verify that the action has in fact been done. It's not a lack of trust in you as an individual, but follows the GMP principle that nothing can be left to chance. Records are kept for very good reasons, not the least being that if any problem about a particular matter or batch should arise in future, the records can be referred to and corrective action taken so the mistake doesn't happen again. No prizes for guessing that change control is all about controlling the inevitable changes that take place. GMP requires that every action is controlled by documented instructions, so to comply, changes to those instructions must be documented, issued, and the obsolete documents replaced. And of course, the physical aspects of the change must also be implemented and documented. And remember, only the current document is valid, so it must always replace any previous version. GMP-compliant change control has a significant impact on many people. Whether the manufacturing centre is called a factory, plant or facility, good manufacturing practice is about making things using only the appropriate equipment. To be GMP compliant, the product must be, that phrase again, fit for the intended purpose. The important point is that the production environment must do nothing to impair the product. The nature of healthcare products means that buildings are often designed for the purpose, or require extensive reworking to install appropriate surface finishes. Air handling, conditioning and filtration must permit control of temperatures and humidity appropriate for the product, while allowing people to work in comfort. In order to reduce the chance of contamination, sterile products are produced under clean conditions, the name given to special, usually called cleanroom environments, fed by high-efficiency air filters, and built using special, non-shedding surface finishes. People wear all-enveloping cleanroom clothing and must follow specific behaviour characteristics, all to limit particle sizes to below 1/200th of a diameter of a human hair. Normally applied to entire cleanroom production suites, clean conditions are also used in more localized formats, including open-fronted clean benches and cabinets, and isolators which, as their name suggests, create clean working conditions completely isolated from the ambient environment. A crucial responsibility for quality control staff is environmental monitoring to ensure that specified criteria are maintained, and must not itself contribute contamination. Precision and accuracy are the key words that best describe GMP manufacturing, with its reliance that everything is measured to fine tolerances, and to ensure that all gauges, dosing heads, weighing machines, and the dozens of other similar instruments are accurate. They must be calibrated and documented at regular intervals to meet specific standards. There's a dastardly rumour that good manufacturing practice doesn't apply to maintenance engineers and technicians because they're different. Obviously a myth, because it does apply to them. Remember the phrase we used right at the beginning, everyone and everything that may have the slightest influence on the product? Just reflect on that word influence, perhaps starting with opportunities to cause contamination or vary existing settings, both of which can happen with, well, everything from water systems to raw material handling, finished goods storage, pipelines, surface finishes, soiled tools, incorrect dress for the environment, and perhaps, perish the thought, non-compliance with SOPs, and We won't go on because it's far more important to stress that everyone who works in a GMP-compliant plant is part of a team, and that team can only be as good as the contribution of the weakest member. Plant engineers are only too aware that they have families, have car accidents, and suffer from conditions that need medication and surgery. The opening headlines said it all. By now, you'll appreciate that a GMP-compliant product must contain only the materials with which it was formulated, specified, and licensed. Anything else in the pack, bottle, ampule, vial, jar, syringe is a contaminant. There are 3 forms of contaminants: inert solids, viable organisms, and chemicals. The inert solids that concern us are very small dust particles, comprising dead skin flakes which we shed in vast quantities every day, fibres from our clothing, paint flakes and other bits of building materials, metal filings from machines and conveyors, bits of rubber from closures, glass and plastics from containers, and fibres from paper and cartons. It's an almost endless list of things that float in the atmosphere, then settle on surfaces, or are suspended in liquids. When we're healthy, our bodies are a battleground because in the hidden and damp parts of us that we don't think about, germ warfare is rampant. On our side are the good guys, the organisms in us and on us that keep our bodies fit and well. Ranged against them are the bad guys who attempt to invade us, beat the good guys, and poison our bodies. The reality is that our normal bodily functions depend on the actions of countless millions of benign bacteria and other microorganisms that can be overwhelmed by the malicious group that causes bowel, stomach, or urinary infections. Open wounds from injury or surgery are at risk from infection by the malevolent organisms or by pyrogens, of which more shortly. The fact is that when we're ill, our natural resistance and immunity is severely reduced compared to our tolerance when we're healthy. Designed to control contamination of any sort, GMP places particular emphasis on viable organisms defined as living things that can reproduce, such as bacteria, fungi, and viruses. They're described as microorganisms because they're extremely small, so small that 1 million will fit on a pinhead. A single bacterium has only a single cell. However, in the right conditions, it subdivides itself roughly every 20 minutes. They also have the ability to multiply very rapidly indeed. So, after a very few hours, with each new cell subdividing itself, it will have bred literally millions of other bacteria. Think how quickly your stomach responds to infected food, and how quickly that tickly feeling in your throat develops into a fully fledged cold or flu, or the speed with which that cut turns septic if not cleaned and disinfected, or athlete's foot. Now, to pyrogens, which are anything that causes a rise in temperature in a living body. In healthcare terms, that means fever-inducing. The outer layer of bacteria may contain highly dangerous toxic substances, including molecules called endotoxins that are in fact pyrogens. So, although pyrogens are not themselves viable organisms, they tend to be present in those that are, and, unfortunately, they remain as high-risk particles even though the living cells may have been killed. Any chemical that's not part of a product specification is obviously a contaminant, but how they get into the product in the first place isn't always so obvious. Generally, it's through cross-contamination, in which a substance is carried from one process to another. It happens when equipment isn't properly cleaned, and materials from process A are carried through to contaminate process B. Cross-contamination also occurs when the chemicals used in a cleaning process aren't thoroughly rinsed off and contaminate the next product. And of course, when you touch one surface, then another, you transfer contaminants and are guilty of cross-contamination. The chemical detergents or surfactants we use when cleaning are effective because they flood the dirty areas and counteract the surface tension and static charges that hold them, release the particles that are then suspended in the solution so that the mop or wiper can remove them bodily. Other chemicals, disinfectants for example, kill microorganisms. We have to take active steps to reduce their number to minimize the risk that they will end up in the product. When this is done depends on the nature of the product and the stage of production. There are many different types of disinfectants, each of which act in different ways and are more or less effective against different types of microorganisms. Some are relatively gentle in their action. For example, the 70% alcohol often used as a hand or glove wash. But it won't kill spores, for which much more aggressive disinfectants are needed. If you're using disinfectants, it's important to check that you're using the right one at the right time, and very important to follow the instructions precisely. And of course, SOPs specify what, when and how everything in the plant must be cleaned and disinfected. The efforts of even the best-run GMP production will be pointless if incoming materials and supplies are either not to specification or become contaminated while stored or moved internally. So GMP also applies to logistics, the inclusive name for warehousing, materials handling and distribution. A fact of life is that vendors who have delivered correctly in the past is no guarantee that they will do so in future. Raw materials and packaging delivered from a supplier cannot be assumed to be satisfactory. They must always be placed in quarantine to await quality control sampling. Correct labelling procedures in stores are crucial, as materials that are past their shelf life or wrongly identified or are contaminated and haven't been quarantined for inspection will almost certainly be hazardous. Materials must be stored in a completely secure and non-damaging way, and it's essential that items being moved are not only the right ones, but that great care is taken with their physical movement. The care of bulk containers, their condition, cleaning and sanitization are clearly essential factors in material handling, as is the general standard of housekeeping in areas which are often more difficult to maintain than others. The handling and storage of finished products is an equally important aspect of warehouse operations. Each product leaving the plant will be influenced throughout its manufacture by the care and attention given when it began its process in storage, and how it will be treated during its final journey to the patient. It's so important that we'll repeat it. The correct label must always be on every container. GMP requires that a patient will be prescribed with exactly the prescribed medicine, and to do this, each product must be clearly labelled so that its content can be easily read with information on strength, quantity, batch number, method of use and expiration date. These are called product labels. Labels are also used throughout manufacture as a form of progress and status documentation. They're divided into two categories. The first, called identity labels, show what things are. For example, the content of containers and equipment. And supply systems must be identity labelled at every stage of activity to indicate the material or product they contain. These must show the batch number, the material code number, and the date. The second category, called status labels, show exactly what is happening to every container or piece of equipment at all times. Where appropriate, they must also show the batch number, the material code number, and the date. As both status and identity labels must be placed on every item, they can often form clearly marked sections of the same label. Labels are so important that there are rules for their use. For example, the control of their storage and handling. Writing on labels must be clear and legible so that they can be read easily. Old labels must always be removed so there can be no confusion as to which one is valid. Any label that doesn't adhere properly and may come off by accident must be replaced. Labels must always be positioned on the body of a container or piece of equipment, never on a lid, as this could be removed and put on something else where the contents or status may be totally different. People and training is the last section of this program, not because they're the last things that matter, but the most important. The success of good manufacturing practice depends totally on people doing the right thing, in the right way, at the right time, first time, every time. That applies to every person, from top management all the way up to those doing the work. The purpose of training is to ensure that each person knows and understands their part in the process, and how to undertake each specific task. It's worth repeating that healthcare products must be made with complete adherence to specifications, to manufacturing packaging instructions and standard operating procedures. Mistakes occur as a result of inadequate training and not following the instructions. Anything else is carelessness. By their very nature, our products require that special attention must be paid to what people wear, both to protect themselves and the product. Remember, our first priority for controlling contamination is to prevent it getting in. Critical to this is that we must wear the right apparel properly at all times and behave sensibly. Even the way we move when working in special environments, for example, clean rooms, can be critical. High standards of personal hygiene must be maintained at all times, of hair, body, and personal clothing. It's in the nature of things that microorganisms have a wonderful time in restrooms, which is why hands must always be washed properly after visiting the toilet. Protective gloves must always be worn when specified. Certainly no product or chemicals should be touched or handled without them. Anyone who has a cold or flu or other infection, or has a cut or graze, must report this to the supervisor and may be given work in areas less sensitive to such ailments. There are also strict rules in warehouse, production areas and laboratories prohibiting eating, drinking, chewing and smoking. If you're on any medication, it must never be taken into the plant, and this applies particularly to antibiotics in case of accidental cross-contamination of products in manufacture. Which really brings us back to where we started, except that you now know how GMP works to prevent all those unpleasant incidents from happening. Today, healthcare products have a fantastic record for product quality, a testimony to good manufacturing practice. Few jobs have greater personal responsibility than yours, making medicines and medical devices. Let's review the why, what and how of GMP. Regulatory agencies license and control the manufacture and sale of healthcare products, ensuring systematic conformity through GMP. The global GMP definition of product quality is that it must reach the customer fit for its intended purpose. This is not a target, it's the minimum acceptable standard. The core principles of GMP are based on the rule that every action will be undertaken only by following written instructions, that raw materials and components must be stored and handled correctly, that equipment and its environment are appropriate, properly cleaned and treated, that products will contain only the specified ingredients, that everything must be identified and labelled at each stage of production and distribution. The most effective way of ensuring quality in a product is to make certain that mistakes don't happen. This is achieved by having two separate but interrelated functions, quality assurance and quality control. Quality assurance entails the systematic analysis of each process in order to pre-plan and document how every activity will be undertaken. This ensures that the outcome will be as expected. Quality control provides the physical verification that it has been or is being done. Quality control samples raw materials, products in manufacture, the utility services such as water supplies, the environment, and that cleaning has been done correctly. The quality department, quality assurance and quality control must ensure that the product is fit for its intended purpose. validate something means to prove and document that it works consistently as specified. Each product is the subject of a validation master plan and must remain validated for its complete life cycle. A properly validated project is cost-effective because it promotes reliable and repeatable production. Documentation provides instructions of what must happen and records of what did happen. Instruction documents include specifications, manufacturing, packaging and other instructions, and standard operating procedures, SOPs, for activities that are not product-specific. Records log what has been done clearly and precisely, and complete with the time and date when it was done, at the time it was done. Incorrect entries must be corrected, dated and signed, not obliterated. Entries should be countersigned by the supervisor or an appropriate colleague. Records are kept so that if problems with a particular batch arise in future, corrective action can be taken. All changes must be documented, reissued, and the obsolete documents replaced. And the physical aspects of the change must also be implemented and documented. Sterile products are produced under clean conditions. The requirement for virtually all other products is that the facility must do nothing to impair product quality. GMP-compliant equipment should be installed with good access, be easy to clean, to set up, and to maintain. Maintenance and engineering is as subject to good manufacturing practice as production. The opportunity to cause contamination arises during every aspect of maintenance, which is often unsupervised during shutdown periods. Anything other than the specified ingredients is a contaminant. There are 3 forms of contaminants, starting with inert solids such as dust particles, and viable organisms that include bacteria, fungi and viruses. Pyrogens are not living organisms, but are anything that causes a rise in temperature and fever in a living body. Chemicals that are not part of a product specification are contaminants, either by cross-contamination that through inadequate cleaning carries a substance from one process to another, or the cleaning chemicals that themselves cause contamination. People who touch one surface and transfer cross-contaminate another. The most effective defense against contamination is prevention. The second is to remove it. If it can't be removed, neutralize it. GMP applies equally to logistics, the name for materials handling and distribution. Raw materials can't be assumed to be satisfactory and must always be placed in quarantine for quality control sampling. Materials must be stored in a completely secure and non-damaging way. The correct label must always be on every container. Identity labels show what things are, and status labels show exactly what is happening at all times. Old labels must always be removed. Labels that don't adhere completely must be replaced. Labels must be positioned on the body of a container or equipment, never on a lid, as this could be removed. The success of good manufacturing practice depends totally on people doing the right thing, in the right way, at the right time, all the time. Training ensures that each person knows and understands their part in the process and how to undertake each specific task. High standards of personal hygiene must be maintained at all times, of hair, body and personal clothing. Protective gloves must always be worn when specified. Anyone who is ill or wounded must report the fact to a supervisor. Eating in warehouse and production areas is prohibited, so is drinking, chewing and smoking. If you're on medication, it must be left securely outside the warehouse or production areas. One final point. The benefits of GMP work only if everyone, and that means you, understand it, respect it, and apply the principles for every minute, of every hour, of every day, of every week, of every month. In fact, all the time.